So we're now up to question number 10 as a shadow for 2018 paper 2. It says a spherical, okay, it's going to be a keyword, cough sweet of radius 6 millimeters is placed into the mouth and sucked. After 5 minutes, its radius has decreased, okay. So I'm just trying to keep track of some of the information. Modeling assumption, the rate at which the radius decreases, right, radius decreases. Inversely, wow, there's a lot of stuff here. Okay, so I think this is the bit that I'm going to start from. So when they say rate, if you're generally not sure, it means it's about time. So this is going to be about the radius and time, so dr dt. It also says that it decreases, and there was a clue here as well about decreasing. So that means we need a minus. Proportional, well, proportional is sort of what I'm doing by making an equation. I also need to put a letter here, k, a constant that links them together. Okay, I could have just written something like this, okay, and then the other bits, but I just jumped straight in with the equal sign. Inversely proportional. Inversely proportional means that the thing is in the denominator and the thing is r squared. Okay, so this is a differential equation that we are able to make. Not really 100% sure what to do with all of this yet, but let's just wait a moment. So the goal is to form an equation linking r and t. So it says r and t. It doesn't say dr and dt. Yes, there's an r, but there's no t. So this is a big clue as well. This is telling me to integrate. Okay. So I'm going to need to integrate in a moment. Now, let's just have a think if it's worth. Sometimes it's worth doing something before you integrate. Sometimes you can sub in here. So let's just read it again. A spherical cough sweet. I'm actually not sure that the spherical bit was as important as I first thought. Its radius has decreased. Okay, so it doesn't say anything about the rate at which the thing is decreasing. So I'm looking at that because if I had this, I could maybe find k, but I don't seem to have that. So I think I'm just going to integrate. I don't think I can do anything else from here. So we're going to separate the variables. So the left-hand side is going to be the r side, and the right side is going to be the t side. So I'm going to say that r squared dr is equal to, the minus can stay where it is, the k, it normally works best if you leave the k where it is, and that's dt. So I'm going to write this, and then I'm going to integrate it. Okay, so if I do that, I would get a third r cubed equals minus kt plus c. Don't forget this plus c. People always forget this plus c on this kind of question. So I've got this one here, and the idea is now that I should try and find out what k and what c are. So I reckon this bit of information up here is going to be helpful. Placed into the math. Right, I think this is t equals 0, isn't it? So this is somebody's way of saying when t is 0, r is 6. Just scanning the units, yeah. Okay, so if I do a third of 6 cubed, it should be equal to minus k times 0, it should be equal to just c. Okay, so this is going to give us our c value. So let's have a quick look. Hang on a moment. I'm not on any useful mode on my calculator at the moment. So 1 over 3, what's that, 6 cubed? So that's 216, isn't it? 6 cubed. So this all turns into 72, so C equals 72. Just make sure I'm leaving enough space. So what we do now is we plug that back into this one here, okay? So I've now got a third r cubed equals minus kt plus 72. And there should be some information to help me try and find this one as well. So after 5 minutes, because I've done this first piece of information, so it's suspicious that I haven't done anything with this yet. So T is 5, R is 6, I think. T is 5, R is 6, yep. So let's do a third, 4 cubed equals minus K, what's T? T is a 5 plus 72. So we can do this one here. We can work this one forward. So this is 64. I think I might just, do I have K? No, I don't have K anywhere. So I guess we're working that one out. So a third of 64, take away 72, divided by minus 5 will give me my K value. So let's type all of that in. So 1, well, I could just do 64 divided by 3, minus 72 divided by minus 5. Divided by minus 5. So that actually gives me a fraction, doesn't it? Okay, hang on. I'm going to do this one properly. So we're going to leave it in fraction form. So 64, take away a 72 and divide it by a minus 5. Gives me 152 over 15. So I can now make a complete equation. So I'm going to put this back into this one now, and it will all sort of be done. So I've got 1/3 r cubed equals minus 152 over 15 t plus 72. Did they ask for anything in particular? No, that should be fine. They didn't say that I had to get the r on its own, so that should be totally fine. Right, we found the model, so part B is going to be, presumably, we're going to use the model. So hence, find the total time for the sweet to dissolve completely. Right. So what would it mean to dissolve completely with our model? It should be useful, our model. I think it just means this bit being a 0, doesn't it? Yeah, let's go with that then. So for part B, well, I think we can jump straight in and we can say 0 equals minus 152 over 15t plus 72. So if I did 72 times 15 over 152, this should give me my answer. And apparently that ends up being approximately 17.5. 17.5 what? 17.5 minutes. Now, it wants it in seconds, so we're going to multiply this. Hang on. Oh, answer in minutes and seconds. Okay, so we're just going to say then 17 minutes and 30 seconds is what I've got. Okay. Finally, suggest one limitation of the model. Well, one good thing to pick on in these kind of questions is this is suggesting... Is this suggesting a constant rate, though? I'm not sure that it is. It's suggesting that there's a uniform rate in how the radius shrinks, but does it take into account if the person gets tired? Because it's taking them 17 minutes. So I think we should say something along the lines of the person might get tired and not able to suck on the sweet at the same rate, or even give up after a while, because 17 minutes is a long time for one sweet, isn't it? Okay, so notice I didn't say that dr/dt was constant. Okay, I was just saying that like the amount of effort or exertion that the person might be putting in might stop, for example. Okay, just because I think contextually that's probably the answer that makes the most sense.